All right, welcome to class, everybody. Happy Monday. And yeah, welcome to week 9. Apparently, we're already here at week 9. Let's see. So, thanks everyone for filling out the survey. I've kind of compiled some trends already, but I think I'm going to look at that one more time before letting you know what sort of themes I saw. But it's really helpful to hear from you, so thanks for taking that time and being thoughtful about how the class is going. Also, just a reminder of what we've got going on right now. So Thursday, Lab 8 is due, and Friday, Project 3 is due. So both of those are going to get you really comfortable working with various kinds of linked lists and writing code for implementing linked lists. So definitely get those done, and we will be we'll actually be thinking about some sort of bigger ideas for data structures today, which are how do we tell that one instantiation of a data structure is the same as another. But then the rest of this week, we're going to also talk about some bigger ideas about how we think about the runtime of functions. And so we will kind of be stepping even bigger than linked lists, but do get those coding projects done. Any questions about the logistics of the class right now? There have been some good questions on Lab 8 and on Project 3, so that's great. Definitely want to make sure that the instructions are clear. But let's jump into today. So, as I said, we are going to be talking about equivalence, and there are some specific things about Java that we're going to talk about. But if you understand the difference between primitive data types and reference data types, and do some thinking about what does it mean for things to be equal, a lot of that is going to carry over to other programming languages. And so you probably, in 127, you should have seen this as well. But as we see it again and again, hopefully it becomes more and more clear. But basically, the big idea that we're going to see today is that when we have primitive data types, like ints, for example, then equivalence testing is easy because int variables just hold a value. All primitive data types, they just hold that value. And so if, for example, we hop over to some Java code over here, and we have on this page, what we're going to write today is mostly in these movie and equivalence and cloning files, but we're going to build that up today. And then we'll also take a look at, we'll add another method to a singly linked list class. So that's finished in here. So if you look at that, you'll see the finished one, but we're going to build it up ourselves. So I'm just working in, I could have made this, but I made a day 22 package, and I have just made an equivalence and cloning class where I have a main function where we're just going to be able to see some examples of testing equivalence. So for primitive data types, things are, like I said, pretty easy. For example, we get intuitive behavior. If I make an int x and I assign it the value of 5, and I make an int y and I also assign that the value of 5, then just as we would expect, if I print out what is returned when I call the equality operator equals equals on x and y, well, those things are true. Or that's true. Those things are equal. And even if I do something, kind of more complicated, but still not that challenging, with a primitive data type like ints, and I say let's make an int z and just make it equal to x. So this, again, I get sort of what I would expect, which is that indeed something like y is equal to x. You know, I had nothing to do with y when I made z, but still, of course, all of these are equal to are 5, so they're equal, right? Okay, that's all intuitive, but as I think we've seen in this class, and also you would have seen in Python, so what we're going to do is let's rebuild our movie class so that we can check equality between movies. So I'm going to make movie again. We've seen this a bunch of times. So my movie class is just going to have a private integer field year and a private string field name, right? And I'm just going to make a constructor that sets these. So I'm going to take in a string n and an int y, and I'm just going to set my year to y and my name to n. Okay, so great, I got my movie class, and let's make some movies. I'm going to say M1, and since the only movie that I even had a guess about what year it came out was when I was writing when we first were doing with movies, was a Harry Potter movie. We will continue with that. So I'm going to make Harry Potter and the Sorcerer's Stone, and I believe that came out in 2001. And great. Okay, so I've got that movie M1, and I'm also going to make movie M2, and well, okay, so intuitively, we're going to want, let's test, does M1 equal M2, right? And intuitively, we kind of want these things to be equal, right? Like, they have the same name, they have the same year. But if I print M1 equals M2, what I get is false. And I think I've kind of alluded to it, but can anybody tell me why I get false back here? What is being compared? Yeah.
Is it checking where they're stored?
Yeah, so it's checking the equality of the actual variable, like M1 is actually really a memory address telling us where this data is stored. And M2 is also a different memory. It's also a memory address, and this data has been stored somewhere else because we initialized these or we declared these and initialized these in this way, so they're different. And so those are different. But on the other hand, if I make a third movie, M3 equals, say, M1. Okay, I guess I gotta actually make it, movie M3, and I say this equals M1. So what this is doing under the hood is it's just creating another reference to this data that's stored somewhere. And so when I print this out, if I say is M3 equal to M1, then I get true. And so this can be hard to keep straight. And so just to make sure it's really clear, I think it's very helpful to actually have this picture in your head of what is going on behind the scenes. And so let's get that going. Oh yeah. Okay, so let's look. We've got M1, M2, and M3. Let's say we write them that way, and I have this data, which is Harry Potter and 2001. And when, oops, there's my data, Harry Potter and 2001. And when I run these two lines right here, I actually make M1 point to that. I make another, I put some data over here, make M2 point to that. And then when I run my movie M3 is M1, can anyone tell me what arrow should I draw? Yeah, I'm seeing some big angles here, right? I don't get to draw it down here to something new. I got to draw it all the way back here. And so this, I think, is a really helpful picture to have in your head when we're thinking about reference data types. And this will come up again later in the lecture. So that's what's going on there. Great. Now, okay, so great. I would say our equals equals operator is not really doing what we want, but we can write our own equals method. So let's actually first think about let's add some methods that we're going to need for our equals method. So our goal is to write an equals method. But to do so, we've made these fields private, so I think that we're going to want a public string get name method, which is going to return us the name, and we're also going to want a public int get year method to return us the year. And so if I want an equals method, so I want to call this, if I go back to my code over here, I want to call this, I'm actually going to just put it in a print statement, but I want to call, say, is M1 equal to M3, say. Actually, let's do I want to be able to call this like this, right? So the method is being called on M1, and it's taking in M2. And, you know, I want this to print, I want this to have the same behavior where I'm going to see true or false depending on whether these are equal. So can anybody tell me what the return type of this method should be? Yeah, Boolean. So we've got that. It's called equals. And what should this take in? Yeah, so this is going to take a movie, and I'll call it other. And so for, let's say, just 3 minutes, you can, by yourself, think about how you could implement this. I bet you can do it in one line. And once you think you have an implementation for this method, tell it to a neighbor. So ask a neighbor how they're doing, and I'll let you know when 3 minutes is gone, but you can kind of awkwardly look around if you're ready. But we can implement that, and yeah, you got 3 minutes to think about that. Okay, turn to a neighbor and ask them what they did.
So I did this. I'm still working on data essentially, right? This title is equal to other title and this gets yours other title return true else return yeah, I just get a little confused. Totally. It's reference this, I believe I'm correct in saying that this references the method that is actually calling it, not the method that you are, not the data that you are passing it into. Yeah, that would make sense. I think it'd be easier. Yeah. I imagine it as a little tiny guy, calling the shots and stuff.
All right. Did any pairs have like two different ways of doing it, or any partnerships have two different ideas? Or was everyone exactly the same? Yeah.
You can just use an if statement, say other dot name is equal to that first one, like this dot name, and other dot year is equal to this dot year.
Yeah, okay, so we can say if other dot get name is equal to name, and so we got to use the double ampersand there, and other dot get year is year, then I should return true, else I should return false. Nice. Did anyone have a way of doing this just in one line? Yeah, I see. How about, yeah. Yeah, exactly. So I can do this as an if-else, but also this statement is going to evaluate to either true or false, and I can also just return that, right? So both would work fine. But the big idea here is we need to compare. I mean, it's pretty easy. We just need to compare this this movie and this movie's name and this movie's year to the other movie's name and year, and getting that into Java is maybe the main challenge there. Okay, so great. That's looking good. Let's just run this and see. Great. Okay, we got what we would have hoped to get there. Did anybody try? Yeah.
If you did this dot title and then the total equals other dot title, would that kind of have the same effect as the name?
Yeah, and I guess so one thing is you can use this, like it's the same to say this dot name and this dot year. I don't have to do it because there's no sort of conflict between the names. And so Java can see, oh, name, that should refer to the name of this instance. But it's really a matter of style, whether you use this dot name. Personally, when there's no name conflict, I usually don't use this dot name. But you'll notice that in some of the starter code, sometimes there is a this dot name when I've taken it from another person that taught this class. And it's really kind of just a matter of style in that case. But the place that you would really need to do it is if you wanted to pass in name here. So now there's two names. There's the local variable name, and then there's the field name. And Java would have a hard time, wouldn't know how to distinguish between these. And so then you'd want to say this dot name. So that would refer to the name here. And I want to assign that to be this local variable name that's being passed in. Yeah, but good question. Cool. Any other questions on this? Yeah.
What about returning this equals other?
I think, yeah, that's a good question. Did you try it?
Yeah.
Did it work?
Yeah.
Oh, wow. So I guess we got to return that. So, okay. Well, so I mean, it worked in that it compiled. Did it give you the right answer?
Yeah, it says M3 equals M1.
Okay, I get M1 does not equal M2. I wouldn't be surprised. I would guess that we would get M3 equals M1 because if we go back to our picture, M3 and M1, they do refer to the same thing. So that is true, but I get that M1 and M2 are not equal when I do that. So I think that's a great idea and good thing to test out, but I think that this is, again, just comparing their memory addresses. Yeah, so, okay, maybe we'll go to this and have a nice short version of this. Cool. Did anybody try writing, does anybody remember from 127, at the end of 127, when you learned about classes and object-oriented programming, you may have done a lot of the built-in method overriding, right? So you may have even overridden the plus, so you got to do something you got to actually call the equals method that you wrote using the equals operator. I don't know. Does anybody remember what I'm talking about? I'm seeing some nods. Great. And I think that's really satisfying that we can actually write in Java or in Python, and this is true in Java as well, but in Python, I'll say it's easy to override the equals operator. So it's easy for us to make it so that we can actually compare M1 and M3 using the equals operator. Did anybody try like seeing whether, now that we've written this equals method, whether it's actually overriding the built-in? Anybody? I see. Did you try it? What did you find? Oh, really? Okay, so let's see. Which one should we? Okay, M1 and M2 are our kind of problem case, right? So this is Lucy's prediction. Is that this is going to return false, even though we've written an equals method. And let's see. We'll make sure that we know which one we're talking about. So let's try equals. And indeed, so we're not actually calling this our equals. And we can double check that. Like if it was, I would also, if I wanted to check whether we're actually calling this, right? I mean, I can see, oh, we're probably not calling it because those should be equal, but you know, what if I want to double check? I want to say in the equals method. And so I'm going to see, okay, yeah, we called it a couple times, but now on our last one, we clearly are not calling, we're not overriding the equals operator, right? Does that make sense? That we've demonstrated that to be true? So, yeah, anybody have any guesses? Like, why aren't we calling it? Yeah, well, okay, so yeah, maybe there's just like not even a way to do it, to link those together, but there is, so there actually is, we can override the equals with our own equals method. In Java, it is possible. I don't know. There's not really any reason why you would guess this. I'm just wondering if there's anything that's coming to anyone's head about what could be going wrong. Yeah. So, that's a good guess, but no, that doesn't actually change. That's kind of just like for the reader of our code. But, so there are actually two things that are going on. So first off, so if we wanted to override the actual equals operator, we would have to match the method signature of that. And to do that, to override the equals, we need to pass in an object first off. So we would have to change movie to object. And just, I'll show you what this looks like just so that if you see it, you'll have reference. So, okay, so now we're passing in an object. And now this method signature actually does match the Java equals method signature. So the same way that like when we wanted to override the toString, so we have public string toString, and if we want, and you know, we can make this return null for now, but if we want, now if I go to print out a movie, if I just do system.out.println M1, then I would actually print null every time because I'm overriding the toString. And that's because this method signature matches Java's method signature. So that's what I mean when I say the method signature matches. But okay, so how do we actually fix this now that we're taking in an object? So what we need to do is we need to actually cast the object to a movie, right? So let's see. First, check whether other is even of type movie, right? If it's not a movie, then they're definitely not equal. So if other dot get class is how we check what the type is. And I could say movie possibly here, but I can also say just call get class on myself, right? So if I'm writing a method in my movie class and I call this method get class, what do you think it's going to return?
Class of the movie.
Yeah, it's a movie. So so the class of this thing, which is type movie. So actually, if these are not equal, then what should I return? False. Yeah, exactly. But, okay, great. So let's say they were equal. So then I can create a movie. Movie O is cast my thing that I took in to a movie type, right? That's how we cast. And now I just have one thing to fix, which is that I'm calling get name and get year on other, but I really should call it on O, right? And so now I should have a working equals method that actually matches the method signature from Java. Any questions on that? On actually getting the class, comparing the class type, casting to a movie? Cool. Yeah.
Does overriding the equal qualifier, does that override it when we're just trying to compare like other data types, or is it just for overriding it when we're comparing objects?
It would just be for movies. So this would just, if we were, this equals method is just defined for movies. If we did something like a subclass of movies, then the subclass could inherit the method. But so, okay. So I really just wanted to show you taking in an object, because this is how you'll see these equals methods in the wild. There's actually another thing that we're actually not going to make it so that we can override the equals operator. We would also need to override the method that gets the hash of the object. And we're not going to do that. So unfortunately, even though we've done that, we still are not calling our equals method, but that's fine, because we do have this equals method, and so if we want to compare to movies, we can compare them. Great. Let's see. What's next? Okay. So cool. So now let's return to the subject of last week, linked lists. And let's write an equals method for linked lists. So I'm going to grab the linked list implementation from last Wednesday. So that's more on linked lists. And so I'm just going to copy this singly linked list over to Eclipse. I'm going to put it in my day 22 package as a new class, singly linked list. And I'm going to paste this in. And I got to change my package name to day 22. But otherwise, we should be good to go. So now inside this package, I have a singly linked list implementation. And it's got a toString, but it doesn't have an equals method. And so let's see how that would look. So we want to write this equals method, but first, let's make ourselves some linked lists. So we've got singly linked list. I'm going to call it S1, and I got to call the constructor singly linked list, and I'm going to add some strings to this. Again, I'll stick with our airports sort of analogy. S2, I'll even call add last, how about? I'll call it, put in SLC. So here I have a singly linked list. Might even print it out since I've got okay, I'm going to put some more printing for myself. Moving on to singly linked lists. And great. Okay, so I've got a singly linked list here, and then I'm going to make a second one, S2, and it's got the same stuff in it. It's got Bozeman and Salt Lake City as the two nodes. I wonder, this feels like something's happening that's wrong. I would have thought, thank you. Okay, great. We got two singly linked lists, S1 and S2, but you can all tell me what's going to happen when I try to print out S1 equals S2. What's this going to tell me? False, because their memory locations are different, even though they hold the same data. So, yep, not the same, according to the equals equals operator. All right. Okay, so we got public Boolean equals, and this is, we're going to just make this take in a singly linked list other. Okay, let me think how we want to do this. So, what is the kind of idea, like how am I going to compare these two? Any ideas from someone I haven't heard from yet? Any thoughts? How can I compare these? Sure. Yeah, we're going to have to walk over both the lists and see if their elements are equal. Yeah. Yeah, probably. That's a good idea. We can try that. Return. So other dot toString is just the toString of this, and we're kind of trusting that, you know, strings have the equals equals operator nicely implemented, and we didn't actually call it yet. So if I want to call this, right, I'm going to have to do s1 dot equals s2. Oh, I actually thought that was going to work. Let's see if I really would have thought that would have worked. Let's try. This is what I would do. This toString is what? It is toString, right? So that's the thing that we're comparing here, and let's just visually inspect, like, what's going on. Other toString is other.toString. And, you know, they look the same.
Pretty much the toString of first string is an extension of piece of data that is pointing to, so it's not pointing to the same piece of data, it's the same toString.
Well, it's
Like it's just a string version of the piece of data, right?
it is actually, it should be a string. So I would say,
Like it's a string that was made from the data.
yeah.
So you're making two different strings for two different pieces of data, even though cosmetically they're the same. Like they're stored in two different places on the computer.
Well, when we actually, it's true that the string is computed from two different places on the computer, but it's like, you know, if you have, let's say, one function computes the square root and it comes back to be 2 from some data, and another function computes the sum of two things and it comes back to the 2. Like, those 2's are still the same that came back from the function, if it's a value.
If I declare two different
Oh, but
strings,
strings are,
yeah, if I declare two different
strings are not,
that means you
are,
get the same
yeah,
string, would it consider those two
yeah, strings are reference data types in Java, probably. Yes, okay, well, yeah. So yeah, I mean, it's a good reminder to review. At the beginning of class, we had a list of what are the primitive data types in Java. They are ints, doubles, chars, etc. You know what wasn't on that list? Strings. And so indeed, strings, even though they feel very primitive to me, they're not actually primitive data types. They are reference data types. And so, yeah, I mean, you were right. We were comparing addresses.
But, I mean, how did that work in the last one where we were comparing the emails?
Yeah, that's a good question.
I have another question.
Yeah.
Instead of doing other.toString equals with the equal sign, could you do compare to?
Yeah, let's try that. Dot compare to toString. Is this? Yeah, we gotta call it. Oh. And then this is probably equals, let's see, compare to returns 0 if they're exactly the same, is my guess. So compare to, yeah, is working. But yeah, that's a good question about. So yeah, we compared equality successfully with our names of our movies, but we didn't compare equality successfully with these in this case. So, I mean, this is just something for me to look into after class. Yeah. I do know there's something in Java, yeah. Mm-hmm. Yeah. Yeah, I mean, it kind of seems like there's something that is not necessarily intuitive, but there's I'm sure there's a reason for it, but, you know, let's just write this down. Great. So yeah, but this is interesting. Comparing the two strings would work, and I mean, I think that would be that could be a valid thing to do when you're writing your own programs. But if we want to actually compare, sort of object by object as we walk along the nodes, then we're going to need to, if we want to walk through the two lists, then we're going to need to be walking along these nodes, right? And so in our remaining couple minutes, let's think about if we wanted to do that, what would we do? So so this was actually slicker, but what's one thing that we could check to see if two linked lists are different? Yeah, so one quick check we can make is compare the size, right? So if the size of what I've passed in is not equal to my size, then I can return false, right? Okay, but now, once I've gotten to this point, okay, if I get here, same size, so I need to check the data. So yeah, someone said we're going to need to walk over the two. What am I going to, what sort of data type am I going to need to create to walk over the lists? Yeah. What'd you say? Yeah, a node. Okay, so I got one node. And what's that node going to be equal to?
I call it walk.
Sure, walk, yeah. Our book likes to call things walk because it's going to walk over.
Yeah. And then that's going to be...
Or you can just, yeah, to head, exactly. Great, so, okay, so now walk is equal to the start node of this list. Great. What else do I need? Yeah, I need another one to walk through the other list. So I'll call it walk other. Ooh, I'm going to use camel case because that's what we've been doing. And how do I get that? Well, let's just other.head. And now I'm just going to walk over the lists. Yeah. You know, that's a good question. And it looks like, well, yeah, it's true. I'm kind of surprised that Java's not. I guess because it's another singly linked list, maybe, that the private modifier's not hurting us. So anyway, we want to walk over these. So as long as, let's say, my walk is not null, I'm going to keep going. So keep walking. How do I do that? Well, I'm going to say walk is walk.next, .getNext, right? And my other walk is walk other.getNext, right? But, okay, that's just how I move down my list. What's the important check that I need to do? It's to check whether they're equal, right? So if they're not equal, then I should return false. Otherwise, keep walking, right? And so the file linked on the website has this implementation. I'll get back to you on this, why this didn't work, and we'll talk about cloning next class. Have a good afternoon. See you on Wednesday.